myself Kalma, lecturer in mathematics. Now I am going to teach a topic in a discrete mathematics 1, unit 3, the fractions and exponents. In this unit we are going to learn about what is meant by the fraction and what is meant by the exponents. What is meant by the fractions in algebraic expression? It is a rational algebraic fraction. Generally the fraction is of the form p by q, where p and q are the integers and q is every time have to be not equal to 0. Then only we define a p by q as a fractions. Similarly, in that manner, the fractions in algebraic expressions also the same. A rational algebraic fraction is an expression which is of the form p by q. Here p and q both are the algebraic expressions, and definitely the q must be not equal to 0. That is, the expression should not be equal to 0. And p and q are called the fractions, and p is called the numerator of the fraction and q is called the denominator of the fractions. By using this, now we are going to find the fractions and exponents in this chapter. The first problem is given: solve x square minus 3x plus 2 by 2 minus x. Here the given p by q format, and the first one is p. In the place of p we have x square minus 3x plus 2, which is a algebraic expression. In the denominator we have 2 minus x, which is also an algebraic expression and which is not equal to 0. Clearly 2 minus x is not equal to 0. Then we can use the algebraic fractions. Here in the numerator we have x square minus 3x plus 2. In the denominator we have 2 minus x. Now we have to find the fractions of the numerator, that is x square minus 3x plus 2. We can find the fractions by producing the first and the third term, which can satisfy the second term, that is 2x square. Now we have to split the 2x square to satisfy the minus 3x. Here for the products of 2 we have only 2 ones are 2. So now the 2 ones are 2 can be easily satisfy the 3x. But the sign we have the minus. We get the minus sign only when we split it into the 2 minus, that is x square minus 3x can be split as minus 2x minus x plus 2, and the denominator we have 2 minus x. Now in the first two terms, that is in x square and minus 2x, we have the common term x, then we get x minus 2. In the second two terms we get common term minus 1. Then by removing the first minus 1, then we get x, and from the 2 when we remove the minus 1 we get minus 2. Then here we get x into x minus 2 minus 1 into x minus 2. Now in the both terms we have the common term x minus 2. When we remove the first term x minus 2, then here we get x. In the second term we get minus 1. Then we get x minus 2 into x minus 1. In the denominator we are taking the minus as the common for the cancellation. Then we get x minus 2 into minus 1. Now when we compare, the first term in the numerator and the denominator was same. Then both terms get cancelled. Then we get x minus 1 by minus 1. We know that if there is a negative sign or a positive sign in a fraction, that is applicable to both the numerator and the denominator. Here in the denominator we have minus 1. Now it becomes the product of the numerator x minus 1. Then we get minus of x minus 1. Now multiply the minus inside the term. Then we get minus x, minus into minus plus 1. Therefore, after solving this fraction x square minus 3x plus 2 by 2 minus x, we get the result minus x plus 1. In this way we find we solve the fractions. In the next same, solve the problem 1 by 1 minus 1 by 1 plus 1 by x. Here we have totally 1, 2, 3, 4 fractions. First we have to solve the fractions in the denominator. First here denominator we have the first fraction is 1 by x. Now we have to take the LCM of x in the denominator. Then we get x plus 1 by x, which results like 1 by 1 minus 1 by x plus 1 by x. When we divide the two fractions, the denominator fraction become the product of the numerator, that is the reciprocal. Then we get 1 by 1 minus x by x plus 1. Now here the denominators are 1 by 1 minus x, 1 by x plus 1. Now we have to take the LCM of x plus 1. Then we get 1 by x plus 1 minus x by x plus 1. Then the denominator become the reciprocal. Then we get x 1 by x plus 1 minus x by x plus 1. Then the result is 1 by x plus 1 minus x by x plus 1. The result is x plus 1 get the reciprocal, then the result is x plus 1 by x plus 1 minus x. Now in the denominator x get cancelled, then we get x plus 1 by 1 which is equal to x plus 1. Therefore the fraction of the given problem is 1 by 1 minus 1 by 1 plus x is x plus 1. In the same procedure, we are going to solve the three algebraic fractions. The third problem is simplify 5 by 2s plus 4 minus 3 by s square plus 3s plus 2 plus s by s square minus s minus 2. First we have to equate the for taking the LCM of the numerators. First we have to solve all the denominators of the given algebraic fractions. The first fraction consists of 5 by 2s plus 4. The denominator fraction is 2s plus 4. Now we have to solve that first. In these two terms, the common term is, it's a 2 multiple. That is 2 into s plus 2 into 2. Now remove the 2 in the common term, then we get s plus 2. In the second term, we have the denominator s square plus 3s plus 2. Now we have to find the fractions of this algebraic expression. That is s square plus 3s plus 2 can be written as s square plus 2s plus 2 plus 2. In the first two terms we have the common term is s. Now remove that common term, then we get s plus 2. In second two terms, that is s plus 2. In these two numbers the common term is 1. Then we get 1 into s plus 2. In both two terms we have s plus 2 common, then we get s plus 2 into s plus 1. And the third one is s square minus s minus 2. This expression can be written as s square minus 2s plus s minus 2. So in this term we can get the common of first two terms is s. Then we get s minus 2. The second term is plus s minus 2. The common term is plus 1. Then we get s minus 2. In both terms we have the common term is s minus 2 and then we get s plus 1. Therefore s square minus s minus 2 can be written as s minus 2 into s plus 1. Now substitute the solving problems in the given expression. Then we get 5 by 2 into s plus 2 minus 3 by, in place of s square plus 3s plus 2 we can write s plus 2 into s plus 1. In the last term we have s by s square minus s minus 2, that can be written as s minus 2 into s plus 1. Now we can solve the problem by taking the LCM of the denominators. In the first term, here we have 2 into s plus 2. That means we didn't have the s plus 1 and s minus 2. For the LCM, we are going to multiply the s plus 1 into s minus 1 to the first term in the numerator and the denominator. In the second term, we didn't have the 2 into s minus 2. So here we going to multiply 2 into s minus 2 in the numerator and the denominator. In the third term, we didn't have 2 into s plus 2. So here we are going to multiply the 2 into s plus 2 in both the numerator and the denominator. Then we result is s into s plus 1 into s minus 2 minus 3 into 2 into s minus 2 plus s into 2 into s plus 2. And the denominator is 2 into s plus 1, s plus 2 into s minus 2. That is the LCM of the three algebraic expressions. Now we have to multiply the given expressions, that is 5 into s into s, that is s square. Next s into minus 2, that is minus 2s. Next 1 into s, that is s. 1 into minus 2, that is minus 2. The second term is minus 3 into 2 into s minus 2, that is 2 3s are 6 into s minus 2. And the next term is s into 2 into s plus 2, that is s into 2s plus 2 into 2, that is 4. Now again solve that expression. The denominator remains the same. That is 5 into s square minus 2s plus s. Minus 2s plus s means minus s and minus 2. Minus 6 into s minus 2 plus s into 2s square plus 4s. And the denominator is 2 into s plus 1, s plus 2 into s minus 2. Then we get 5 into s square minus s minus 2, that is 5s square minus 5s. Now here we have 6 into s minus 2, that is 6x minus 6 into minus 2, that is plus 12, plus s into 2s plus 4, that is 2s square plus 4s. And the denominator is 2 into s plus 1 by s plus 2 into s minus 2. Then now compare the terms and add the algebraic expressions in the term. That is 5s square plus 2s square, which results 7s square. Next, minus 5s minus 6x plus 4. First one, minus 6s plus minus 5s, that results minus 11s plus 4h, which results minus 7s. The constant is plus 12 minus 10, which results 2. Therefore, the result is 7s square minus 7s plus 2 by 2 into s plus 1 into s plus 2 into s minus 2. Therefore, by simplifying the three fractions, that is 5 by 2s plus 4 minus 3 by s square plus 3s plus 2 plus s by s square minus s minus 2, results that 7s square minus 7s plus 2 by 2 into s plus 1 s plus 2 into s minus 2. Similarly, we can solve the next problem, that is simplify r minus 1 by r square plus r minus 6 minus r plus 2 by r square plus 4r plus 3 plus 1 by 3r minus 6. Now write the given expression first given. Now we have to simplify this fraction. Now in the denominator, the first term consists is r square plus r minus 6. That can be written as r square plus 3r minus 2r minus 6. That means r can be written as 3r minus 2. Here we are using the fractions. Now then, in the first two terms, we have the common term is r. It results r into r plus 3. In the second two terms, we have the common term minus 2. From the first term, when we remove the minus 2, we results r. And from the second term minus 6, when we remove the common minus 2, we get the 3. Now in the first two terms, we have the common term r plus 3. By removing it as a common, then we get r. In the second term, we are minus 2. Then we get r plus 3 into r minus 2, that is r square plus r minus 6 have the fractions r plus 3 into r minus 2. Similarly, we have finding the fractions of the second term, that is r square plus 4r plus 3. It can be written as r square plus 3r plus r plus 3. In the first two terms, we have the common term r. When we remove the common term r, the result is r plus 3. In the next two terms, that is r plus 3, the common term is only 1. So that's why we have removed the common term 1. Then the result is r plus 3. In the first two terms, we have the common term r plus 3. And when we remove the common term r plus 3, the first term consists of only r and the second term consists of plus 1. Therefore, r square plus 4r plus 3 can be written as r plus 3 into r plus 1. And the third expression is 3r minus 6. In these two terms, the common term is 3. Clearly, we can write as 3r minus 6 as 3 into r minus 2. Now, substituting these fractions in the given algebraic fractions, then we result r minus 1 by r plus 3 into r minus 2 minus r plus 2 by r plus 3 into r plus 1 plus 1 by 3 into r minus 2. Now taking the LCM for these three algebraic fractions, we get 3 into r plus 1, r minus 2 into r plus 3. In the first term, we didn't have the fraction 3 into r plus 1. So we have to multiply and divide the first expression with the 3 into r plus 1, which results as r minus 1 into 3 into r plus 1. In the second term, we didn't have the r minus 2 into 3. So that's why we have to multiply and divide the second term with 3 into r minus 1 in the numerator and the denominator. In the third term, we didn't have the r plus 1 into r plus 3 term. So that's why we have to multiply and divide the third term with that expression r plus 1 into r plus 3, which results as r minus 1 into 3 into r plus 1 minus r plus 2 into 3 into r minus 2 plus r plus 1 into r plus 3. In the denominator we get the LCM 3 into r plus 1 into r minus 2 into r plus 3. Now we have to do the general multiplication. First you have to multiply 3 into r minus 1 into r plus 1. Here we can find a formula a plus b into a minus b, which results a square minus b square. So we get 3 into r square minus 1. Here we have the plus. Next r plus 2 into 3 into r minus 2. Here also we find a formula r plus 2 into r minus 1, that is r square minus 2 square. Here we get minus of 3 into r square minus 2 square, plus last term is r into r square, plus 3 into 1 3r, plus 1 into r plus 1 into 3. After multiplying these equations, we get that 3r square minus 3r square plus 12 plus r square plus 4r by 3, and the denominator is 3 into r plus 1 into r minus 2 into r plus 3. Now do the general addition of the algebraic addition, that is 3r square minus 3r square, which results 0 plus r square, then we get r square. The next term is rth term, that is only we have 4r, and the constant is 12 plus 3, which results 12 plus 3 means 15. Here again we get another term which we didn't note here, so r square plus 4r plus 2 by 3 into r plus 1 into r minus 2 into r plus 3. So next chapter is in this unit exponents. What is meant by first an exponent? When we producing a positive real number for n number of times, then we use this positive exponent some a power n. Here n is a positive integer and a is a real number. First, what is meant by positive exponent? Here n be a positive integer and a is the real number, then a power n is called a positive exponent. Here a in a power n, it means a is done a product of n times. In a power n, we called a as a base and n is called the power or exponent. Similarly, we can define the negative exponent. Here n is a positive integer and a is the real number. A is the real number, then we get that a power minus n can be defined as 1 by a power n. Here definitely a should not be equal to 0. This expression is called a negative exponent. For positive exponent, we have some examples. X square. X square can be written as x into x. That means we are doing the product of x the 2 times. And 3 power 5. That is we are producing the 3 with 5 times. That is 3 into 3 into 3 into 3 into 3. That is 5 square can be written as 5 into 5. And the next definition is negative exponent. In the negative exponent, we have some examples. 1 by 4 power 5. It can be written as 4 power minus 5. Here 5 is a positive integer and 4 is the real number. But in a power, we get the negative sign. That's why it's called a negative exponent. Similarly, we have some examples. 1 by 3 power 4, which is equal to 3 power minus 4. And 6 power minus 4, which can be written as 1 by 6 power 4. And the next one is root. Here n is a positive integer. If we have a comma b are 2 real numbers, then a power n can be written as b. Then a is said to be nth root of b. Here we use the symbol square root, that is nth root of b can be written as a power 1 by n. Now here we have an example, 4th root of 16. That is 4th root of 16 can be written as 4 square and that term can be written as 2 power 4. That is 4th root of 2 power 4 can be written as 2 power 4 whole power 1 by 4. Here we written a power 1 by n is equal to nth root of a. Similarly, in place of a we have 2, in place of n we have 4. then result is 2. Here we used the formula a power m power n, which is equal to a power mn. And next we have some formulas in this section. That is, first one, a power m by b power ab power m, that can be written as a power m by b power n. Now second term is a power m into a power n, which is can be written as a power m plus n. When the bases are equal, the powers or exponents can be added. The next one is ab power m, that can be written as a power m into b power m. Similarly, in the roots also we can define that is m root of ab can be written as m root of a into m root of b. And the fifth term is m root of n root of a can be written as mn root of a. By using these formulas, we are going to solve the problems in the chapter 2 exponents. Also, we have some basic formulas, that is a power 0 equal to 1. If a not equal to 0, when a is not equal to 0, then only this is applicable. Next, second one is a power m power n, that is a power mn. Next one, a power m by a power n, that is a power m minus n. It is also can be written as 1 by a power n minus m. And next one is nth root of a power n, which can be written as a power m by n. Now next one is m root of a by b, that can be written as m root of a by m root of b. By using these formulas, we can also solve the problems in the next section also. Here we have an example, 30,000 into 9,000. Here, when we have a large number or a small number, we have to use the scientific notations. That is, we can separate the number by using the 10. Here, if it is a large number, we can product the number with a 10 power, and if it is a small number, we can divide the number with 10 power. That is, we are using here positive exponent and negative exponent. Here in a place of the real number, we have to use the 10. That is, 30,000 can be written as 3 into 10 to the power of, here we have 4 zeros, that's why 10 power 4. And 9,000 can be written as 9 into 10 to the power of 3. Here 3 into 9 results 27, and 10 power 4 and 10 power 3. Here we use, when the bases are equal, the powers must added. We use the formula a power m into a power n, that is a power m plus n. That is 27 into 10 to the power of 7. It results 27 into 0, 0. Here we have 10 power 7, then we get 7 zeros. By using this scientific notation, we can multiply the large numbers or small numbers with an easy process. Here we have an example. Here given 0.125 power 1 by 3 and 0.25 power minus 1 by 2. That means they are the small numbers. Now we have to divide the number with 10 power after the decimal. That means here after decimal we have 3 digits. That means we have to divide the number with the 10 power 3. Then we get 125 by 10 power 3 whole power 1 by 3. Here we have 0.25, that can be written as 25 by 10 square whole power minus 1 by 2. Now 125 can be written as 5 cube, that is 5. 5s are 25, 25. 5s are 125. So 125 can be written as 5 cube, and 10 by 10 cube whole power 1 by 3. Similarly, 25 can be written as 5 square by 10 square. That is, 25 can be written as 5 square by 10 square whole power minus 1 by 2. Here we use the formula, that is a power m by b power m, which is equal to a by b power m. By using that formula, we get 5 by 10 whole power 3 by 5 by 10 whole power 1 by 2. That 1 by 2 can be written as minus 1 by 2 in negative exponent. A power minus 1 can be written as 1 by a. In this way, we can get 5 by 10 whole power 3 by 3, 5 by 2 whole power 2 by 2. 3 3 get cancelled and 2 2 get cancelled. Then we get 5 by 10 by 5 by 10. When we divide two fractions, the denominator fraction become the reciprocal. Then we get 5 by 10 into 10 by 5. 5 5 get cancelled and 10 10 get cancelled, which results 1. Therefore, the value of 0.125 power 1 by 3 into 0.25 power minus 1 by 2 is 1. Thank you.